Welcome to the solutions to the AP Physics equilibrium problem set. The solution to number 14. Let's read the problem first and see what kind of issues we have here. The chewing muscle, the masseter, is one of the strongest in the human body. It is attached to the mandible, lower jawbone, as shown in the diagram below. The jawbone is pivoted about a socket just in front of the auditory canal. The forces acting on the jawbone are equivalent to those acting on the curved bar shown below to the right. Fc is the force exerted by the food being chewed against the jawbone. T is the tension in the masseter, and R is the force of the socket on the mandible. Find T and R for a person who bites down on a piece of steak with a force of 50 newtons. As we take a look at the curved bar mentioned here to the right, you can see that they've already done the free body diagram for you. You have Fc down, and we're told in this problem that that is 50 newtons. We're asked to find the tension in the masseter upward and the R value, which is the force of the socket on the mandible, down. The issue that we have in this problem is that you can see that all our forces are in a vertical plane. We have no forces in a horizontal plane. So what we have here are two unknowns in the same direction, or at least in the same plane. The problem is we don't have, if we have two unknowns, it requires two equations, and we don't have a second force direction. There are no horizontal forces or any components that we can use to get one of the values. Okay? So the issue with these equilibrium problems is that there's too many unknown forces preventing us from just summating forces. Where does the third equation, the third approach, come from? And as probably you suspected, as mentioned earlier, we're going to get that third approach, that third equation, by summating torques, therefore eliminating one of the unknown forces perpendicular to the lever arm. When doing this, you intelligently select the pivot point to your advantage. Okay? So, if we take a look at this, we're going to summate torques to get one of the forces and use that answer then in a summation of forces vertically to get the other force, if that makes sense. To do that, we need to intelligently select a pivot point by which to eliminate one of the forces causing torque. It does not make sense that we would pick a pivot point at Fc because we know that value, and by picking that pivot point we still have two unknowns if we were to summate the torques. I'm just going to select a pivot point at the spot where force T, the tension, connects to the jawbone. You could actually do this by selecting the pivot point at either this spot or at where R attaches to the jawbone. All right, so we start with here a summation of torques equals 0. We have the 50 Newton force, which is perpendicular to the lever arm at 7.50 centimeters. You may have questions there, shouldn't we be using meters? I'll get back to that in a second. The answer is no, we don't have to. Now we need to consider its rotation. By itself, it would cause the jawbone, Fc would cause the jawbone to rotate counterclockwise around the pivot point that we've selected, so its torque is positive. Then we have force R, and notice what they've given here is the horizontal distance, the 3.50 centimeters, is the horizontal distance between T and R, which is nice because that's the lever arm. If they had given the angle distance, you would need to know an angle so that you could calculate the horizontal lever arm. R, by itself, would cause the jawbone on the right side to go down and rotate about our selected pivot point in a clockwise direction, therefore is negative. Solve this equation for R, and we get 107 newtons. Couple things here. Note that by selecting our pivot point, T is eliminated as causing torque because T doesn't have any lever arm, since the pivot is at that spot. There's no distance between the pivot point and where the force is attached. The second point here is that notice we left our lever arms all in centimeters. That's because it all shakes out in the end, and centimeters units gets canceled anyways in calculating the torque, in calculating the force. So as long as your units are all the same units all the way across, you don't have to convert to standard units when summating torques. All right, now we can proceed with the rest of the calculation, and we're going to do a sigma F in the y direction, which is 0. We have T up minus the 50 newtons down minus the 107 newtons we just calculated down equals 0. So T is equal to 157 newtons. So there we found the values that they were looking for, the force of the socket on the mandible and the force of the tendon on the mandible as well. And we did this by summating both torques and forces. So this was your introductory problem in which we're going to use both methods by which to solve for forces. And we could also do it to solve for lever arms. So more on this to come as we do problems 15 and 16 in class tomorrow.